Hi there, you're in the lab with your mate JJ. Today is Quick Study Cheat Sheet Review. This is a new segment for the show, a new feature of the show. We haven't done one before. There's I have various cheat sheets. There are a multiplicity of them, but in the main they're these quick study academic cheat sheets or subject outlines, maybe you call them. They call it an academic outline. And they're basically a laminated fold out. It's a 6-page fold out with a very small print that tells you about an entire subject. And we've got well, we've got quite a number of them actually. I'll show you the full set in just a second. What I'm planning to do is just take them over to the bench and then read through the pages 1 through 6 and just have a look at everything that's in here. This particular one, which is the one we'll be doing first, is called Pre-Algebra. So it's stuff that you should know before you do algebra. And I've basically got them sort of listed in dependency order. So this is one of the earliest things to look at. Look, I'll take you over to the wiki and I'll show you the notes I've got for all of them. Hang on a sec.
All right, so I'm just firing up my web browser here, and we'll just jump over to the ITL wiki, which is the wiki for the show. It's all going a bit slowly. My computers are busy. Now, I've got Quick Study here, so I'll just click on that. And this is the list of Quick Study cheat sheets that I have. So for mathematics, I've got pre-algebra, elementary algebra, algebra 1, algebra 2, geometry 1, geometry 2, trigonometry, pre-calculus, calculus 1, calculus 2, calculus equations and answers, differential equations, statistics equations and answers, probability, linear algebra. And then I've got science, I've got physics, physics 2, physics thermodynamics, dynamics, physics equations and answers, chemistry, chemistry equations and answers, periodic table, advanced. Engineering, engineering formulas, electronics 1, electronics 2, circuit analysis, electrical. I guess it's electrical engineering. Programming, Linux, SQL programming, C++ programming language, Python 3 programming language, Python 3 standard library, Excel, Excel tips and tricks, Excel formulas, Excel 365 formulas, Excel pivot tables and charts, finance, financial statements, writing, writing tips and tricks, Chicago Manual of Style, English grammar and punctuation, common grammar pitfalls and mistakes. So this is the order that we'll be going through them in. And we'll be doing, I'll try to do one every week. So today we're going to start with pre-algebra. I have no idea how long it's going to take. It might take hours and hours and hours. We'll see. Let me throw you back over to the bench and let's have a look at our first one.
All right, well, here we are on the bench, and this is our first quick study academic outline. So as I said, it's a 6-page foldout. This is the front page, and then page 2, page 3, page 4, page 5, and page 6. So hopefully the glare isn't too bad on this thing and we can sort of have a read of it. Yeah. So I don't know how this is going to go, but let's see what it's like. Let's see what happens. So the first section is number systems. The following sets are infinite. That is, there are no last numbers. The 3 dots indicate continuing or never-ending patterns. So the counting or natural numbers are 1, 2, 3, 4 through 78, 79 through to infinity. Whole numbers are all of those numbers plus 0. And then the integers is all of the whole numbers, including 0 and the natural numbers, with the negative numbers. And then we've got rational numbers, all numbers that can be written as a fraction, P on Q, where P and Q are integers and Q is not 0. Rational numbers include all counting numbers, whole numbers and integers, in addition to all proper and improper fraction numbers, and ending or repeating decimal numbers. For example, 4 on 9, 0.3 repeater, negative 18.75, the square root of 16, and negative square root of 25. Irrational numbers. All numbers that cannot be expressed as rational numbers. As decimal numbers, irrational numbers do not end or repeat. Wow. Example is pi, the square root of 7, and the negative square root of 2, and pi. Okay, 317117117. Yeah, right. Real numbers. All rational and all irrational numbers. The reals, okay. Oh, okay, cool. So the irrationals and the rationals are the reals. Very good. Now we've got another section called operations. Absolute value. Absolute value is the distance, always positive, between a number and 0 on the number line. The positive value of a number. For example, the absolute value of 3 is 3, the absolute value of minus 3 is 3, and the absolute value of minus 0.5 is 0.5. Addition. 1. Integers. When adding integers, follow these rules. A. If both numbers are positive, add them. The sign of the answer will be positive. B. If both numbers are negative, add them. The sign of the answer will be negative. If one number is negative and the other one is positive, in any order, subtract the two numbers, even though they are joined by a plus sign. The sign of the answer will be the same sign as the sign of the number that has the larger absolute value. For example, 4 plus negative 9 is negative 5. Negative 32 plus negative 2 is negative 34. And negative 12 plus 14 equals 2. 2. Rational numbers. A. When adding two mixed numbers, fractions, or decimal numbers, follow the same sign rules that are used for integers above, but also follow the rules of operations for each type of number. For mixed numbers and fractions, make sure the fractions have a common denominator, then add the numbers. Mixed numbers and fractions can also be changed to decimal numbers and then added. C. For decimal numbers, line the decimal points up, then add the numbers, bringing the decimal point straight down. For example, minus 4.5 plus 5 3/4 equals minus 4 2/4 plus 5 3/4 equals 1 1/4. 5.667 plus 0.877 equals 4.79. Okay. Irrational numbers. When adding irrational numbers, exact decimal values cannot be used. If decimal values are used, then they are rounded and the answer is only an approximation. Instead, if the two irrational numbers are multiples of the same square root, radical expression, or pi, then simply add the coefficients, the numbers in front of the roots, or pi. For example, 4 times root 3 plus 5 times root 3 equals 9 times root 3. Or minus 6 pi plus 9 pi equals 3 pi. Or 3 times root 7 plus 3 times root 2 cannot be added any further because the two square roots are different. Subtraction. Subtraction of all categories of numbers can be accomplished by adding the opposite of the number to be subtracted. After changing the sign of the number in and back of the minus sign, follow the rules of addition as stated above. For example, 8 minus negative 3 equals 8 plus 3 equals 11. And minus 15 minus 9 equals minus 15 plus minus 9, which equals minus 24. Multiplication. Integers. When multiplying integers, follow these rules. If the signs of the numbers are the same, multiply and make the answer positive. If the signs of numbers different, multiply and make the answer negative. Note, the sign of the answer does not come from the number with the larger absolute value as it does in addition. For example, minus 4 times 5 is minus 20, minus 3 times minus 2 is 6, and 7 times minus 10 is minus 70. Rational numbers. When multiplying rational numbers, follow the sign rules that are used for multiplying integers above and the rules for multiplying each type of number. For mixed numbers, change each mixed number to an improper fraction and then multiply the resulting fractions. For fractions, multiply the numerators and the denominators, then reduce the answer. D. For decimal numbers, multiply them as though they were integers, then put the decimal point in the answer so there is the same number of digits behind the decimal point in the answer as there are behind both decimal points in the problem. 3. Irrational numbers. When multiplying irrational numbers, follow the same sign rules that are used for integers listed above. If radical expressions are multiplied and they have the same indices, then the numbers, the radicands, under the root symbols, the radicals, can be multiplied. For example, minus square root of 5 times the square root of 7 equals minus the square root of 35. 3 times the square root of 7 times minus 4 is minus 12 times the square root of 7. Division. Integers. When dividing integers, follow these rules. If the signs of the numbers are the same, divide them and make the answer positive. If the signs of the numbers are different, divide them and make the answer negative. The sign of the answer does not come from the number with the larger absolute value as it does in addition. For example, minus 30 divided by 5 equals minus 6, minus 22 divided by minus 2 is 11, and 70 divided by minus 10 is minus 7. Rational numbers. When dividing rational numbers, follow the sign rules that are used for dividing integers listed above and the rules for dividing each type of number. For mixed numbers, change each mixed number to an improper fraction, invert or flip the number behind the division sign, and follow the rules for multiplying fractions. For decimal numbers, first move the decimal point in the divisor to the back of the number, then move the decimal point the same number of positions to the right of the dividend. Divide the numbers, then bring the decimal point straight up into the quotient, which is the answer. Additional zeros can be written after the last digit behind the decimal point in the dividend so the division process can continue if needed. Irrational numbers. When dividing irrational numbers, follow the same sign rules that are used for dividing integers listed above. If radical expressions are divided and they have the same indices, then the numbers, radicands, under the root symbols, the radicals, can be divided. For example, negative square root of 15 divided by the square root of 3 equals negative the square root of 5. Okay. And the square root of 30 divided by negative the square root of 6 equals negative the square root of 5. And the cube root of 4 divided by 4 cannot be divided, only simplified, as demonstrated in the Quick Study Algebra Part 1 study guide. Interesting. All right, we're going to go on with exponents. I'm just going to take a break, get something to eat. That's better. I was hungry. I just went and had Vegemite on toast in the best Aussie tradition. So now I'm ready to keep on keeping on. I really have no idea how long it's going to take. We've just scratched the surface. We're what, 3/4 of the way through the first page. So on we go. Exponents and powers. Definition. A to the n equals a n a's. That is, the number written in the upper right-hand corner is called the exponent or power, and it tells how many times the other numbers, called the base, is multiplied times itself. If an exponent cannot be seen, it equals 1. For example, 5 to the power of 6 is 5 times 5 times 5 times 5 times 5 times 5, which equals 15,625. Notice that the base, 5, was multiplied times itself 6 times because the exponent was 6. Rule: a to the n times b to the n equals the a to the power of m plus n. That is, when multiplying the same base, the new exponent can be found quickly by adding the exponents of the bases that are multiplied. For example, 5 to the power of 3 times 5 to the power of 4 equals 5 to the power of 7. 3 to the power of 2 times 7 to the power of 3 times 7 to the power of 2 times 3 to the power of 5 equals 3 to the power of 7 times 7 to the power of 5. Rule: a to the power of n divided by a to the power of m equals a to the power of n minus m. That is, when dividing the same base, the new exponent can be found quickly by subtracting the exponents of the bases that are divided. The new base and exponent go together in the numerator or in the denominator, wherever the highest exponent was located in the original problem. For example, 7 to the power of 5 divided by 7 to the power of 2 equals 7 to the power of 3. And 3 to the power of 4 divided by 3 to the power of 6 equals 1 divided by 3 to the power of 2. Right. Rule: a to the power of minus 1 equals 1 on a. And 1 on a to the power of minus 1 equals a. That is, a negative exponent can be changed to a positive exponent by moving the base to the other section of the fraction. Numerator goes to denominator, or denominator goes to numerator. For example, 7 to the power of negative 3, 1 divided by 7 to the power of 3, 1 divided by 5 to the power of minus 2, or 5 squared, 3 times 2 to the power of minus 4, and 3 times 2 to the power of 4. Notice that the 3 stayed in the numerator because the invisible exponent is always positive 1. Rule: a to the n to the power of m equals a to the power of n times n. That is, when there is a base with an exponent raised to another exponent, then the shortcut is to multiply the exponents. For example, minus 3z squared cubed equals minus 3 cubed times z squared to the power of 3, which equals minus 27 z to the power of 6. Order of operations. When a problem has many operations, the order in which the operations are completed will give different answers. So there is an order of operations rules. Do the operations in the parentheses or any enclosure symbols first. Do any exponents or powers next. Do any multiplication and division going left to right in the order they appear. This means division is done before multiplication if it comes first in the problem. Do the addition and subtraction going left to right in the order they appear. This means subtraction is done before addition if it comes first in the problem. And then there's a whole bunch of examples. There you go. Now, we're up to page 2. Scientific notation. A form of decimal number where the decimal point is always behind exactly one non-zero digit and the number is multiplied by a power of 10. For example, 4.87 times 10 to the 8 or 3.981 times 10 to the minus 6. It is a method for representing very large or very small numbers without writing a lot of digits. For example, this massive number would be written as 2.437 times 10 to the 14, or this very small number would be written as 9.82 times 10 to the minus 7. A positive or zero exponent on the 10 means the number value has more than or equal to 1. Yeah. A negative exponent on 10 means the number is less than 1. For example, 5.29 times 10 to the minus 10 equals this very small number, and 5.29 times 10 to the 14 is this very big number. Operations with very large or very small numbers can be completed using the scientific notation form of the numbers, especially with calculators. Algebra concepts. Definitions. A variable is a letter that represents a number. A coefficient is a number that is multiplied by the variable. It is found in front of a variable, but the multiplication sign is not written. If the coefficient is 1, the 1 is not written. For example, 5n equals 5 times n. If n were 3, then 5n would equal 5 times 3, or 15. A term is a mathematical expression involving multiplication or division. Terms are separated by an addition or subtraction sign. For example, 7a is one term. 3k plus 9 is 2 terms. 4m squared minus 8m plus 3 is 3 terms. Like or similar terms are terms that have the same variables and exponents, written in any order. The coefficients, the numbers in front, do not have to be the same. For example, 4m and 9m are like terms. 5a squared c and minus 7a squared c are like terms. 3r cubed and minus 9r squared are not like terms because the exponents are not the same. 15z to the power of 4 and 8t to the power of 4 are not like terms because they do not have the same variables. Operations and properties. Addition and subtraction. Only like or similar terms can be added or subtracted. Once it is determined that the terms are like terms, only the coefficients, numbers in front of the terms, are added or subtracted. For example, 3n plus 7n minus 11n equals 10n minus 11n equals 10n plus minus 11n equals minus 1n, or simply negative n. 14k squared plus 5n plus 10k squared minus n equals 4k squared plus 4n. Multiplication. Any terms can be multiplied. They do not have to be like terms. When multiplying terms, multiply the coefficients and the matching variables. For example, minus 3m squared n and 5m to the power of 4n equals minus 15m to the power of 6n squared. Remember, when multiplying, make sure the bases are the same, then add exponents. Division. Any terms can be divided. They do not have to be like terms. Division is usually written in fraction form. When dividing terms, divide or reduce the coefficients, the numbers in front, and the matching variables. Remember that to divide with exponents, you must subtract the exponents once you match the same bases. For example, 30a to the power of 7c squared divided by minus 6a to the power of 4c to the power of 3d squared equals minus 5a cubed divided by cd squared. Because 30 divided by negative 6 is minus 5, a to the power of 7 divided by a to the power of 4 is 8 cubed, c cubed divided by c squared is c, and there is no other variable d to divide by the d squared, so it remains the same. Commutative property. A plus b equals b plus a, and a minus b equals a plus minus b equals minus b plus a. Therefore, terms can be moved as long as you take the proper sign, negative or positive, with the term. For example, 4p squared plus 8p cubed equals 8p cubed plus 4p squared. 14c minus 3f equals minus 3f plus 14c. Associative property. A plus B plus C equals A plus B plus C, and A minus B minus C equals A minus B, A plus minus B minus C. Yeah, right. Therefore, terms can be added in any order as long as all subtraction is first changed to addition. For example, 5j minus 8j equals 5j minus 8j minus 12j equals 5j plus minus 8j plus minus 12j. Distributive property. A outside of B plus C equals AB plus AC, and A outside of B minus C equals AB minus AC. Therefore, if the terms inside the parentheses cannot be added or subtracted, multiply them both or all by the value located in front of the parentheses. For example, 3n times 5n plus 6 equals 15n squared plus 18n. Yeah. And a squared c outside of 5a squared plus 2ac minus c squared equals 5a to the power of 4c plus 2a cubed c squared minus a squared c cubed. Double negative property. Minus a equals a. Therefore, if there is a negative of a negative, it becomes positive, just like a negative number times a negative number equals a positive number. Translating. Putting words into algebraic statements. There are several key words or phrases that often help in converting words into algebraic statements. Addition. Plus, add, more than, increase by, sum, total. For example, 4 more than a number becomes 4 plus n. A number increased by 3 becomes 3n plus 3. Subtraction, minus, subtract, decrease by, less than, difference. Example, 6 less than a number becomes n minus 6. It cannot be written as 6 minus n because the 6 is being taken away from the number, not the other way around. A number decreased by 5 becomes n minus 5 and not 5 minus n. Always consider which value is being subtracted. Multiplication, times, multiply, product of, when used with a fraction, doubled, tripled. Example, 2/3 of a number becomes 2 over 3 times n. The product of 7 and a number becomes 7n. Division, divided into, quotient, a half divided by 2, a third divided by 3. Example, a number divided by 2 becomes n on 2. The quotient of 8 and a number becomes 8 divided by n. Inequality and equality symbols. Greater than comes from is greater than or is more than, and not more than, which is addition. Right. Less than comes from is less than and not less than, which is subtraction. Greater than or equal to is more than or equal to, or is greater than or equal to, is less than or equal to, is not equal to, is equal to, or equals. Algebraic equations. Properties. Addition and subtraction property of equality. If A equals B, then A plus C equals B plus C, and A minus C equals B minus C. That is, you can add or subtract any number or term to or from an equation as long as you do it on both sides of the equal sign. 2. Multiplication and division property of equality. If A equals B, then AC equals BC, and A divided by C equals B divided by C when C is not equal to 0. That is, you can multiply or divide any number or term as long as you do it on both sides of the equal sign. Remember, do not divide by 0 because it is undefined. 3. Symmetric property. If A equals B, then B equals A. That is, two sides of an equation can be exchanged without exchanging any signs or terms in the equation. Example, 3n plus 7 equals 8 minus 2n becomes 8 minus 2n equals 3n plus 7. Solution methods, first degree, one variable. Solving an equation means you are finding the one numerical value that makes the equation true when it is put into the equation in place of the variable. Using inverse operations is the best method for first-degree equations. Using inverse operations mean you do the operation opposite to the one in the equation. One-step equations. Equations having only one operation, plus, minus, times, or divide, when the variable require only one inverse operation. If the equation has addition, then you do subtraction. If subtraction, you do addition. If multiplication, do division. If division, do multiplication. For example, n plus 7 equals minus 3. 7 is added to n, so subtract 7 from both sides, and then you get n equals minus 10, giving the solution of minus 10. Example 2, a on 3 equals 9. A is divided by 3, so multiply both sides by 3, and you get a equals 27, giving the solution of 27. Two-step equations. Equations that have two operations connected to the variable require two operations that are the opposite of the ones that are in the equation. It is much easier to do addition or subtraction before doing multiplication or division. This is the opposite of the order of operations because you are doing inverse or opposite operations to solve the equations. Example 1, 3x plus 4 equals minus 8. 4 was added, so subtract 4 on both sides, and you get 3x, and then after you've done that, 3 was multiplied, so divide 3 on both sides, and then you get x equals minus 4, giving the solution of minus 4. Example 2, n divided by 2 minus 7 equals 3. 7 was subtracted, so add it to both sides, and then n is divided by 2, so multiply 2 on both sides, n equals 20, giving the solution of 20. B, if the equation has the variable on the right side of the equal sign, then it can be solved leaving the variable on the right side, or it can be turned around by simply taking everything on each side of the equal sign and putting it on the opposite side without changing any signs or terms in any way. This is the symmetric property. 5, more than two equations. Equations sometimes require simplifying each side of the equation separately before beginning to do inverse operations. For example, 3 outside of 2n plus 1 plus 9 equals 4n minus 10. Distribute the 3, we do that, and then we add like terms, and now we begin the inverse operations. So we subtract 4n from both sides, and then we subtract 12 on both sides, and then we divide both sides by 2, and we get n equals minus 11, which is the solution. Proportions. Equations in which both sides of the equal sign are fractions. The cross multiplication rule can be used to solve such equations. The rule is that if a on c equals b on d, then ad equals bc. For example, 5 on x equals 3 on 7. 5 times 7 equals 3 times x. Cross multiply, inverse operation, divide by 3, and the solution is 11 2/3. Example 2, 4 on 5 equals 3 on x plus 2. So cross multiply, distribute the 4, inverse operation for the 8, divide by 4 for the inverse operation, and x equals 1.75 is the solution. Graphing solutions. Since equations have only one solution, the graphs of their solutions are simply a solid dot on the number line on the real number line. For example, if you solve the equation 4k minus 7 equals minus 15 and found the answer k equals minus 2, then you would draw a real number line and put a solid dot on the line above minus 2, such as above right. Alright, so we've done 2 pages out of 6, and we're ready to keep on keeping on. I'm going to go get a drink first though. Alright, well now we're up to algebraic inequalities. Algebraic inequalities are statements that do not have an equal sign but rather one of these symbols: greater than, less than, greater than or equal to, less than or equal to, or not equals. Properties. Addition, subtraction property of an inequality. If A is greater than B, then A plus C is greater than B plus C, and A minus C is greater than B minus C. Also, if A is less than B, then A plus C is less than B plus C, and A minus C is less than B minus C. This means that you can add or subtract any number or terms to or from both sides of the inequality. Multiplication, division, property of inequality. If A is greater than B, then AC is greater than BC, and A on C is greater than B on C, only if C is a positive number. If C is a negative number, then A is greater than B becomes AC is less than BC, or A divided by C is less than B divided by C. Note that if 8 is greater than 5 and you multiply each side by minus 2, then you get minus 16 is greater than minus 10, which is false. But if you turn the symbol around, getting minus 16 is less than minus 10, it becomes true again. Caution, turn the symbol around only when you multiply or divide by a negative number. Solution methods. First degree, one variable. Solving inequalities is exactly the same as solving equations as discussed on page 2, with only one exception. The exception is when you multiply or divide by a negative number, the inequality symbol turns around to keep the inequality true, so you will get a true solution. The symbol does not turn around when you are adding or subtracting any terms or numbers, or when you are multiplying or dividing by a positive number. For example, 3 outside of x plus 2 is greater than minus 15. So we distribute the 3 and you get 3x plus 6 is greater than minus 15. And then you invert the negative 6, so you invert the plus 6, so you subtract 6 from each side, and then you inverse the 3 and you get x is greater than negative 7, which is the solution. And there was no division by a negative number there. Note, the symbol did not turn around because the division was by plus 3 and not minus 21. So, graphing solutions. Inequalities have many solutions or answers, so the graphs of the solutions look very different from the graphs of equations. Graphs of equations usually have only one solid dot. But the graphs of inequalities have either a solid dots or rays with open dots with rays. For example, if the solution to an inequality is x greater than negative 7, the graph above is with an open dot because minus 7 does not make the inequality true, only numbers more than negative 7 do. The solid dot shows that the number is part of the answer, but an open dot shows that the number is not part of the answer, but only the beginning point. For example, if the solution is n is greater than or equal to 3, the graph above right shows a solid dot. I'll be back. Today in Australia, it's Melbourne Cup Day, which is a horse racing day. And I had a bet on the Cup, and just now I won. I just won $150 because my horse won, called Half Yours. So there we go. It's my lucky day. Anyway, that's enough of that. Let's keep on with the mathematics here. So we're up to the coordinate plane. We're going to talk about points. 1. The coordinate plane is a grid with an x-axis and a y-axis. 2. Every point on a plane can be named using an ordered pair. 3. An ordered pair is two numbers separated by a comma and enclosed in parentheses, x and y. The first number is the x number, the second number is the y number. For example, 3 minus 5, where x equals 3 and y equals minus 5. The point where the x-axis and the y-axis intersect or cross is called the origin and has the ordered pair 0, 0. The x number in the ordered pair tells you how far to go to the right if positive or to the left if negative from the origin 0, 0. 6. The y number in the ordered pair tells you how far to go up if positive or down if negative, either from the origin or from the last location found by using the x number. Lines and equations. The coordinate plane and ordered pairs are used to name all of the points on a plane. 2. When the points form a line, a special equation can be written to represent all of the points on the line. 3. Since points are named using ordered pairs with x numbers and y numbers in them, equations of lines, called linear equations, are written with the variables x and or y in them. For example, 2x plus y equals 5, or y equals x minus 6, or x equals minus 2, y equals 5. Lines that cross both the x-axis and the y-axis have equations that contain both the variables x and y. Lines that cross the x-axis and do not cross the y-axis have equations that contain only the variable x and not the variable y. 6. Lines that cross the y-axis and do not cross the x-axis have equations that contain only the variable y and not the variable x. Slope of a line. 1. Every line has a slope except vertical lines, which have no slope. The slope can be thought of as a kind of a slant to the line. 2. Slope is found by comparing the position of any 2 points on the line. 3. Slope is y1 minus y2 divided by x1 minus x2. It is also described as the rise over run, or the change in y over the change in x. For example, on the right, on the graph at right, the slope of the line L1 can be found using the formula slope equals y1 minus y2 on x1 minus x2 equals 0 minus minus 2 over minus 2 minus 1, which is 2 over minus 3 equals minus 2/3, or slope equals rise over run up to over negative 3, 2 over 3, minus 2 on 3. Notice that the values from the same point are aligned vertically, and the formula y2 minus y1 over x2 minus x1 also works. Yeah, right. Graphing lines. There are many ways to graph a linear equation. Pick any number to be the value of the x variable, put it into the equation for the x, and then solve the equation for the y. This gives one ordered pair, xy, with the number you picked followed by the number you found when you solved the equation. You should pick at least 3 different values for x and solve, giving 3 points on the line. If the 3 points don't form a line, a mistake has been made on at least one of the equation solutions. Example, the linear equation x plus 2y equals 4 can be put into a chart like the one above. Okay. 2. Find the points where the line crosses the x-axis, called the x-intercept, and the y-axis, called the y-intercept. A. This can be done by putting a 0 into the equation for the x variable and solving for the y. This gives the point where the line crosses the y-axis because all points on the y-axis have x numbers of 0. Next, put a 0 into the equation of the y number and solve for x. This gives you the point where the line crosses the x-axis because all points on the x-axis have y numbers of 0. For example, the linear equation 3x minus y equals 5 could be put into a chart like the one above. C. Find one point on the line by 1, putting a number into the equation for the x and solving for the y. 2. Next, use the slope of the line. The slope can be found in the equation. Look at the coefficient, the number in front of the x variable. Change the sign of this number and divide it by the coefficient of the y variable. This is the slope of the line. Then, graph the point you found and count the slope from that point using rise over run. For example, the linear equation 2x minus y equals 7 goes through the point 3 minus 1. The slope is minus 2 minus 1 because you change the sign of the number in front of the x variable and divide it by the coefficient of the y variable, which is minus 1. Graph these values as above, right? The slope-intercept form y equals mx plus b can also be used where m is the slope and b is the y-intercept. Graphing inequalities. On the coordinate plane, linear inequalities are line graphs with a shaded region included either above or below the line. 1. graph the line even if the inequality does not include the equal sign. You must graph the corresponding equality. Pick a point above the line. 3. Put the number values for x and for y into the inequality. See if they make the inequality true. 4. If the point makes the inequality true, shade that side of the line. 5. If the point makes the inequality false, shade the other side of the line. 6. The actual line is drawn as a solid line if the inequality includes the equal sign. 7. The actual line is drawn as a dashed line if the inequality does not include the equal sign. For example, graph x plus y is less than 2. Finding linear equations. 1. Some linear equations can be found by observing the relationship between the x numbers and the y numbers. For example, a line with the points 3, 2, 5, 4, minus 2, minus 3, and minus 5, minus 6 has the equation y equals x minus 1, because every y number is 1 less than the x number. 2. Some linear equations require methods other than simple observation, such as the slope-intercept form of a linear equation. See number 4 below. The standard form of linear equations is ax plus by equals c, where a, b, and c are integers. 4. The slope-intercept form of a linear equation is y equals mx plus b, where m represents the slope and b represents the y-intercept of the line. One way to find the equation of a line is to find the y-intercept, where the line crosses the y-axis, and the slope, and then put them into slope-intercept form of a linear equation. A. Find the y-intercept, then use it to replace b in y equals mx plus b. Next, find the slope of the line and use the slope to replace the m in y equals mx plus b. C. The result is the equation of the line with the number values in place of m and the b in the form y equals mx plus b. For example, b equals 2 and m equals minus 5 on 2, the equation y equals minus 5 on 2x plus 2, or in standard form, 5x plus 2y equals 4. All right, now we're up to page 4. This is geometry, plane geometry. 1. Plane geometry refers to geometry of flat surfaces or planes. 2. Lines are always straight and continue forever in two opposite directions. 3. Points are always named using capital letters. 4. Lines are named using any 2 points on a line. A line with an arrow on each end is drawn on top of the 2 capital letters that name the points, like RS. 5. Definitions. A line segment is 2 points on a line, the endpoints, and all of the points between them. The notation for a line segment is the 2 endpoints in capital letters with a bar over them. For example, line segment PQ, written PQ, is shaded in blue on the line PQ. A midpoint is the point in the center of a line segment. It separates a line segment into 2 equal parts. A ray is 1 point on a line, the endpoint, and all of the points on the line continuing on from the endpoint and going in one direction forever. The notation for a ray is the endpoint, followed by any other point on the ray, with the ray pointing always to the right, drawn on top of the 2 capital letters. For example, the ray AB, written AB with the arrow, is shaded in blue on the line AB. Okay. D. Intersecting lines cross or touch in exactly 1 point. They are always coplanar in the same plane. E. Perpendicular lines intersect or cross, forming 90-degree angles at the point of intersection. F. Parallel lines go in the same direction and never touch. They are always coplanar in the same plane. G. Skew lines go in different directions and never touch. As a result, they are not coplanar not in the same plane. An angle, H. An angle is the union of two rays with a common endpoint. The common endpoint of the two rays becomes the vertex of the angle. The two rays become the sides of the angle. Angles are measured with protractors and in degrees. 1. Acute angles have measures less than 90 degrees. 2. Right angles have measures equal 90 degrees. 3. Obtuse angles have measure greater than 90 degrees but less than 180 degrees. Straight angles have measure equal to 180 degrees. I. Complementary angles are two angles whose measure total 90 degrees. J. Supplementary angles are two angles whose measures total 180 degrees. K. Adjacent angles are angles that share a common vertex and one common side with no common interior points in the region located between the two sides of an angle. For example, the angle ABC and the angle CBD are adjacent angles because they share BC and no interior points. ABD and CBD are not adjacent angles because CBD has side BC inside ABD. Note, the symbol angle means angle and the vertex must be the point written in the middle. L. Vertical angles are lines. L. Vertical angles are angles that have the same vertex and whose sides form lines. For example, KMN and RMP are vertical angles. KMR and NMP are also vertical angles. M. Corresponding angles of three intersecting lines are two angles with one angle having its vertex and one side on the side of the other angle. The other two sides of both angles go on the same side of the first sides. For example, angle ABC and angle BDE are corresponding angles. N. Alternate interior angles are two angles that have one side of each angle overlapping and forming a line where the other sides of the angles go in opposite directions from different vertices, plural of vertex. For example, angle MNP and angle NQP are alternate interior angles. Note, if corresponding angles are approximately equivalent to, I'm not sure what that means, or alternating interior angles are approximately equal, then two of the lines are parallel. Circles. Circles are points in a plane that are all equidistant, the same distance, from the center point. The center point is not part of the circle. 1. Chords are line segments with endpoints on a circle. 2. Diameters are chords that go through the center of the circle. 3. Radii, plural of radius, are line segments with endpoints in the center of the circle and a point on the circle. They are half the length of the diameter of the same circle or of congruent circles. Circumference is the distance around a circle. The formula is C equals pi d. 5. Area is pi r squared. All right. Polygons. Polygons are closed plane figures whose sides are line segments joined at the endpoints. Regular polygons have all angles equal in degrees and all sides equal in length. This is not true if the polygon is not a regular polygon. Special polygons. Triangles are three-sided polygons. The sum of the angles in a triangle is 180 degrees. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. Triangles can be classified in two ways, by their angles and by their side lengths. By angles: right, 190-degree angle; obtuse, one angle greater than 90 degrees; acute, all angles less than 90 degrees. Or by sides: scalene, no equal sides; isosceles, two or more equal sides; and equilateral, all sides equal. Okay, so an isosceles triangle and an equilateral triangle is also an isosceles triangle. I didn't know that. The Pythagorean theorem. The Pythagorean theorem can be used to find the length of one side of any right triangle when given the length of the other two sides. It is usually written as a squared plus b squared equals c squared, where a and b are the lengths of the two legs and c is the length of the hypotenuse. For example, we've got one here with a equals mystery, b equals 5, and c equals 7. To find the length of a, we solve for a and we get 4.899. Cool. Trig functions. Trigonometric trig functions of an angle can be used to find the measures of the angles and the lengths of the sides of right triangles. 1. There are 6 trig functions that are ratios, but only 3 will be discussed here. A. Sine of an angle. Sine A equals opposite over hypotenuse. Cosine of an angle, cos A equals adjacent leg over hypotenuse. And C, tangent of an angle, tan A equals opposite leg over adjacent leg. And of course, that's SOHCAHTOA, right? SOHCAHTOA, SOHCAHTAO, SOHCAHTOA. Some things to note. A, the A represents an acute angle in the right triangle. B, the leg of the right triangle is considered either the opposite leg or the adjacent leg. B, the leg of the right triangle is considered either the opposite leg or the adjacent leg. Changes depending on which of the acute angles of the right triangle is being evaluated in the trig function. C, the opposite leg of a right triangle is the leg that does not touch the vertex of the angle named in the trig function. The adjacent leg of the right triangle is the leg that does touch the vertex of the angle named in the trig function. For example, when evaluating the trig functions for the angle A in this right triangle, leg A has the opposite leg for angle A because it does not touch point A. However, leg B is the adjacent leg for angle A because it does touch point A. The hypotenuse is side C. In the same right triangle, leg B is the opposite leg for angle B because it does not touch point B. However, leg A is the adjacent leg for angle B because it does touch point B. F. Notice, the opposite leg for angle A is also the adjacent leg for angle B, and the adjacent leg for angle A is also the opposite leg for angle B. 3. Since trig functions are ratios, or fractions, they are often converted to decimal numbers. 4. Using the trig function decimal number values to find or use angle measures requires either a trig function chart or a calculator with trig function options. For example, using a chart or a calculator, find the sine 30 degrees gives the decimal number 0.500. Using a chart or a calculator, find the angle K that has tan K equals 1.983 gives the angle measure of 56 degrees. 5. Triangle trig applications. There are 2 basic ways in which trig functions are used with triangles. To find angle measures and to find sine lengths. To find angle measures, to find the 2 acute angle measures when given 2 sides of a right triangle, it is easiest to find the length of the third side first. For example, in the right triangle at right, if you know the length of any two sides, then you may use the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, to find the length of the third side. 2. Once the three side lengths are found, not necessary, but it is easier, use the trig functions to find the degree measure of one acute angle. All right, now we're up to page 5. Continue 3. Using the same right angle above, the measure of A can be found using any of the trig functions, so just pick one of them. See right. 4. The measure of the second acute angle may be found by simply subtracting the measure of the acute angle just found from 90 degrees. Finding side lengths. To find the side lengths of a right triangle when given only one side and side length and one acute angle, first subtract the given acute angle measure from 90 degrees. Second, use the trig function to find the length of another side of the triangle. 2. Once two sides of the triangle are known, use the Pythagorean theorem to find the length of the third side. Quadrilaterals. Quadrilaterals are four-sided polygons. Parallelograms are quadrilaterals with opposite sides parallel and equal in length. Opposite angles are equal in measure, and any two consecutive angles next to each other are supplementary. Trapezoids are quadrilaterals with one pair of opposite sides parallel and the other pair of opposite sides not parallel. Trapezoids are not parallelograms. Parallelograms are not trapezoids. Rectangles are parallelograms whose angles each measure 90 degrees. Sides may or may not be equal. Some rectangles are squares. Rhombi, plural of rhombus, are parallelograms whose sides are all equal in length. Angles may or may not be equal. Some rhombi are squares. Squares are rectangles whose sides are all equal. Squares are also rhombi whose angles are each 90 degrees. This means that all squares are both rectangles and rhombi. Pentagons are five-sided polygons. Hexagons are six-sided polygons. Heptagons or septagons are seven-sided polygons. Octagons are eight-sided polygons. Nonagons are nine-sided polygons. Decagons are 10-sided polygons. N-agons are polygons with n number of sides. Angles, diagonals, congruent, similar. There are a few special relationships about polygons in general. To find the sum of the measures of all angles in a polygon, take the number of sides, subtract 2, and multiply by 180 degrees. The formula may be written as 180 outside of n minus 2, where n equals the number of sides of the polygon. A nonagon has 9 sides, so 180 times 9 minus 2 equals 180 times 7 equals 1260 degrees in total. To find the measure of each angle of a regular polygon, angles all have the same measure. Find the measure of the sum or total of all the angles and divide by the number of angles in the polygon, same as the number of sides. For example, if the total of all angles of a nonagon is 1260 degrees, then divide by 9, equaling 140 degrees for each angle. To find the total number of diagonals, segments whose endpoints are vertices of the polygons, excluding sides of the polygons, of a polygon, take the number of sides of the polygon, subtract 3, multiply by the number of sides, and divide by 2. The formula may be written as n times n minus 3 on 2, where n equals the number of sides of the polygon. For example, an octagon has 8 sides, so 8 times 8 minus 3 divided by 2 equals 8 times 5 over 2 equals 40 over 2 equals 20 diagonals. Congruent polygons are polygons that are the same size and the same shape. There we go. That's the symbol for congruent. We saw that earlier and I wasn't sure what it was. Congruent polygons are polygons that are the same size and the same shape. Same size, same shape. The symbol is congruent. They can be placed on each other using flip slide, or rotate, so equal parts match. Okay, cool. So, similar polygons are the same shape, but not necessarily the same size. They can be the same size, but they're not necessarily. They have matching angles. And have the same degree measures. Congruent polygons are also similar. Similar polygons can be placed in each other so that the matching equal angles are on one side inside the other. Corresponding or matching sides have lengths that are proportional. For example, given below. Areas and perimeters. 1. The perimeter, P, distance around, of any polygon can be found by adding the lengths of all of the sides. 2. The area, A, of each polygon is found using the formula listed in the following chart. Area is measured in square units because it is the number of squares that are needed to cover the surface of a region. The square area is A equals H times B. And the rectangle area equals A times HB, okay? And triangle area equals half B times H. And the parallelogram area is AHB. And the trapezoid area is 1/2 H times B1 plus B2. Okay. The circle area is pi r squared, and the circumference is just pi d, or 2 pi r. Spatial shapes. Polyhedrons. A polyhedron is a closed three-dimensional spatial shape made with 4 or more polygons that have common sides. A. The polygons are the faces of the polyhedron. 1. The line segments of the polygons are the edges of the polyhedron. 2. The vertices of the polygons are the vertices of the polyhedron. B. Prisms are polyhedrons with two parallel congruent bases and sides that are parallelograms or rectangles. C. Pyramids are polyhedrons with one base and sides that are triangles. 2. Cylinders, cones, and spheres. Cylinders are spatial shapes with two parallel bases, congruent circles, and a curved surface joining the bases. B. Cones are spatial shapes with one base, a circle, and a curved surface joining the base that comes to a point. C. Spheres are spatial shapes made of all points equidistant, the same distance, from one central point. 3. Volume and total surface area. The volume V is the number of cubes needed to fill a spatial shape. Therefore, it is measured in cubic units. The total surface area is the sum of the areas of all the faces or surfaces of a spatial shape, measured in square units because it is area. So the rectangular prism volume is length by width by height. The cube volume is E cubed, where E is the edge. Cylinder volume, pi r squared H, okay. Cone volume, 1/3 pi r squared on H. That's interesting. Triangular prism volume is the area of the triangle times H. Rectangular pyramid volume, 1/3 area of rectangle times H. And sphere volume, if radius equals R5, then V equals 4 pi r cubed on 3. There you go. All right, now we're up to the last page. So what have we got here? Ratio, proportion, and percent. Ratios are comparison of two numerical values or quantities. Forms include 3:7, 3:7, 3:7, or 3:7. Okay, that's ratios. Percents are comparisons of Percents are comparisons of numerical values to 100. So they are values out of 100. Percents can be changed to equivalent fractions or decimal numbers and vice versa. A. To change a percent to an equivalent fraction, take the numerical value and put it over 100, then reduce to lowest terms. For example, 30% equals 30 divided by 100 equals 3/10. B. To change a fraction to percent, change the denominator, bottom, to 100. The numerator, top, is the percent value. Fractions can also be changed to decimal numbers and then changed to percents. C. To change a percent to a decimal number, move the decimal point 2 places to the left and remove the percent sign. It is moved 2 places because 2 decimal places is hundredths, just as percents are hundredths or out of 100. D. To change a decimal number to a percent, move the decimal point 2 places to the right and put the percent sign after the number. 3. Proportions are equalities between two ratios or fractions. Forms include 3:4 as 12:16, or 3:4 as 12:16, and 3/4 equals 12/16. A. There are basically two ways to solve a proportion. Get a common denominator for the two fractions. For example, 3 on 7 equals n on 21 becomes 9 on 21 equals n on 21, so n equals 9. Or 2, use cross multiplication, which states that if a on b equals c on d, then ad equals bc. For example, 3 on n equals 4 on 5 becomes 3 times 5 equals 4 times n, then 15 equals 4n, and 3.75 equals n. Compound interest. Formula. A equals P outside of 1 plus R on n to the power of nt, where A is the total amount, P is the principal, money saved or invested, R is the rate of interest, usually a percentage per year, T, time expressed in years, and N, number of periods per year. For example, John put $100 into a savings account at 4% compounded quarterly for 8 years. How much was in the account at the end of 8 years? Percentage decrease. Formulas. Percentage decrease over 100 equals amount of decrease of original value. Or original value times percentage decrease equals amount of decrease. If not given, the amount of decrease equals the original price minus the new value. For example, the Smith Company had 12,000 employees in 1993 and 9,000 in 1994. Find the percentage decrease. The amount of decrease is 12,000 minus 9,000 equals 3,000, and the percentage decrease is n on 100 equals 3,000 divided by 12,000, so n equals 25, and the decrease is 25%. Commission. Formulas. Percentage commission equals commission divided by sales. Or dollar sales times percentage commission equals commission. For example, Missy earned 4% on a house she sold for $125,000. Find her dollar commission. Percentage commission equals 4 in 100 equals commission divided by 125,000, or 125,000 times 4% equals commission, so commission equals $5,000. Percentage increase. Formulas. Percentage increase over 100 equals the amount of increase over the original value, or original value times percentage increase equals amount of increase. If not given, the amount of increase may be found through this subtraction. New value minus original value equals the amount of increase. For example, the Smith Company had 10,000 employees in 1992 and 12,000 in 1993. Find the percentage increase. The amount of increase is 12,000 minus 10,000 equals 2,000. So the percentage increase is n on 100 equals 2,000 out of 10,000. So n equals 20, and the percentage increase is 20% because percentage means out of 100. Discount formulas. Percentage discount on 100 equals amount of discount of original price, or original price times percentage discount equals discount. If not given, dollars discount equals original price minus new price. For example, the Smith Company put suits that usually sell for $250 on sale for $150. Find the percent discount. Percentage discount is n on 100 equals 100 divided by 250, so n equals 40, and the percentage discount is 40%. Simple interest. Formula: I equals PRT, or total equals P plus I, where I equals interest, P is the principal money borrowed or lent or saved, the rate is the percent rate, and time is expressed in the same period as the rate. For that is, if the rate is per year, then time is in years or part of a year. If rate is per month, then time is in months. Example: Carolyn borrowed $5,000 from the bank at 6% simple interest per year. If she borrowed the money for only 3 months, a quarter of a year, find the total amount she paid the bank. Percent interest equals PRT. 5,000 times 0.6 times 0.25 equals $75. Notice that the 6% was changed to 0.06 and the 3 months to 0.25 of a year. The total is principal plus interest, which is 5,000 plus 75 equals 5,075. Markup formulas. Percentage markup over 100 equals dollar markup over original price, or original price times percentage markup equals dollars markup. If not given, dollars markup equals new price minus original price. For example, the Smith Company bought blouses for $20 each and sold them for $44 each. Find the percent markup. A dollar markup equals 44 minus 20 equals $24. Percentage markup equals n on 100 equals 24 and 20, so n equals 120, and the markup is 120%. Profit formulas. Percent profit out of 100 equals dollar profit out of total income, or total income equals times profit equals dollar profit. If not given, dollar profit equals total dollar income minus dollar expenses. For example, the Smith Company had expenses of $150,000 and a profit of $10,000. Find the percentage profit. Total income, total dollars income, $150,000 plus $10,000 equals $160,000. Percent profit equals n on 100 equals 10,000 over 160,000, or 160,000 times n equals 10,000. In either case, the percentage profit is 6.25%. Percent expenses or costs. Formulas. Percent expenses over 100 equals dollar expenses divided by total dollar income, or total dollar income times percent expenses equals expenses. For example, the Smith Company had a total income of $250,000 and $7,500 profit last month. Find the percent expenses. The expenses is $250,000 minus $7,500 equals $242,500. Percentage expenses equals n on 100 equals $242,500 on 250,000. So n equals 97, and the percent of expenses is 97%. IS and OF. Any problems that are or can be stated with percent and the words is and of can be solved using these formulas. Formulas. Percentage over 100 equals is number and of number, or of means multiply and is means equals. What percentage of 125 is 50? 50 over 125, n times 125 equals 50. In either case, the percent is 40. And what number is 125 of 80? So Well, that's 125% of 80. So 125 and 100 equals n on 80, or 1.25 times 80 equals n. In either case, the number equals 100. And that's it. We got to the end. And what does this say here? Notice to student. This quick study guide outlines the major topics taught in pre-algebra courses. For further detail, see Algebra Part 1, Algebra Part 2. Due to its condensed format, however, use it as a pre-algebra guide and not as a replacement for assigned coursework. Okay. So, I'm going to throw you over to the farewell cam. We'll wrap up. That's a wrap. So, yes, today was the inaugural quick study academic outline. We got through our 6 laminated pages. I don't know exactly how long it took, but probably a little while. We'll know when we put the video together. So I'm about to find that out when I edit this thing and schedule it for release. So yes, that was pre-algebra. Check the show notes for a link to it on Amazon. And that concludes this video. So I hope you enjoyed this video. Thanks very much for watching, and please remember to click like and subscribe.